Alright, so here we go on problem 6. I am going to do a hypothesis test. I know that they ask you a series of questions. We're going to answer those questions pretty much as we go through this deal. So here's your output. There's your graphs. Okay. So, is this straight enough? There's a little curve to it, but it's straight enough to proceed. My residual plot is not does not show a pattern, and then my histogram down here of the residuals is roughly unimodal and symmetric, and then my normal probability plot here is it's a little funky, but it's straight enough to proceed. There's not a there's some curvature in it, but we're going to proceed with testing a linear model here. Okay, so let's do this deal. So our parameter here obviously is going to be big B is the linear relationship between the price and age of a car. Okay. My null is that big B is 0. The alternative is that it's not. The assumptions and conditions. The plot is straight enough. So the scatter plot is straight enough. The residual plot shows no pattern. Okay. Prices of cars tends to be independent. And why do I say that? Well, here's the deal. If you look at cars, a car that's let's say 4 years old, they're kind of close to each other. 5 years old is kind of close to each other. 6 years old, I mean, they're kind of close to each other, but one is not influencing the other. So we're going to leave that as it's independent. And then the histogram of the residuals is unimodal and roughly symmetric. Name the test. This is a linear regression t-test. Test statistics. So here's my slope line right here. Okay, I had 17 right here. I had 17 points with 15 degrees of freedom. So I'm going to go through this. N is 17, degrees of freedom is 15. B sub 1 is negative 924. Standard error of the slope is 82.29, and then the y-intercept is 12319.6. So I'm going to write the linear regression equation here. So I'm going to do predicted price equals 12319.60. So that would be the predicted value of a brand new car minus 924 times years. Okay. Obtain P. T equals B sub 1 minus 0 over the standard error. right? And we already know what that is. That's going to be like negative 11.2. It's right there. So if you want to check it out, you can. Let me just check it out just to make sure we're on the right page here. Negative 924 divided by 82.29. And we get 11.2, so that's good. Okay, so let's draw a two-tailed deal. Okay, so we got t is negative 11.2, t is positive 11.2. Our p-value again is less than 0.0001. So we got to make a decision. So we reject each of O at the 0.05 level. And the conclusion, since p is less than 0.001, there is strong evidence of a linear relationship between the price and age of a Toyota Corolla. And I should have changed this up here. This right here this should be of a Toyota Corolla. It's not of just all cars. So when we talk about our parameter, B is about the price and age, the linear relationship between the price and age of a Toyota Corolla. Okay, so I'm going to start talking now about R squared. What's R squared? It's 89.4%. It's right here. Okay, it's 89.4%. So R squared equals 89.4%. So 89.4% of the variation in price of a Toyota Corolla is explained by variation in age. Alright, and then the second thing I'm going to do is I'm going to find out what R is, so I'm going to do the square root of 0.894. And I'm going to get our correlation is like 0.95, right? So R, now remember your scatter plot's negative, it's right there, so R is negative 0.95. So there is a strong negative linear relationship between price and age of a Toyota Corolla. And that should wrap it up.